In this question, we're going to use the sum or difference identity and possibly the symmetry identities to find the exact value of sine of negative 75 degrees. So you can, using the sum or difference identities, we need to find two numbers that are on the unit circle, 2 degrees that are on the unit circle that we can stick in for alpha and beta into our identity. So we could use either addition or subtraction. There's a lot of different options here. I personally found it's the number that I found that adds to 75 was actually a positive 75. So I used the purple identity here, the symmetry identity for sine, which is that sine of negative 75 degrees is going to give me a negative of sine of 75 degrees. So I found it easier to find two numbers on the unit circle that add to 75 rather than negative 75. So that's what I used. So my first step was to convert it to this. And then to find sine of 75 degrees, I broke that up into a negative sine. And then instead of 75 degrees, I did a 30 and a 45. And that's where I'm going to start using this blue identity, this guy here. So alpha, I'll let alpha be 30 degrees, and beta is 45 degrees. Then I get sine of 30 degrees times cosine of 45 degrees. It's a plus sign. With sine function, I alternate trig functions and keep the same sign. And then I'm going to alternate my trig function. So I have cosine of 30 degrees and sine of 45 degrees. And I have a negative out in front of all of this. So I need to kind of remember that. Okay. Excuse me. So now this I can evaluate with my unit circle because 30s and 45s are both on my unit circle. So I'm going to replace actually let's start with the stuff that we know. So I'm going to keep the negative and the brackets, or parentheses, and now I'm going to plug in what I know. So a sine of 30 degrees from my unit circle is 1/2, and that means my cosine of 30 degrees is radical 3/2. And the cosine of 45 degrees is radical 2/2. And sine of 45 degrees is radical 2/2. And I have that plus sign in the middle. So this equals a negative, and then for the first two fractions I have radical 2/4 plus the second two fractions I get radical 6. Radical 3 times radical 2 gives me radical 6/4, and I can add those because I got a common denominator there. So I get a negative out in front of radical 2 plus radical 6 all over 4. And I can distribute that negative, so I get negative radical 2 minus radical 6/4 is my final answer. Which is equivalent. I think I have the in the answer key a little different. I think it might be negative 6 minus 2, but I can switch those around since addition is commutative, so I can switch the order. Not commutative. Yeah, commutative, that's right, commute.